In this part of the tutorial, I'll be telling you about manifests in Graphene. A manifest is a file that for each app that you want to run in Graphene describes a set of runtime configuration parameters and mappings of host files into a virtualized view. So under runtime configuration parameters, this includes configuring debugging support or adding environment variables to the runtime, as well as some SGX specific features like the number of threads and the size of the enclave. A big part of the work that I'll illustrate shortly is about creating a virtualized view of the file system. So for instance, I may want to map a system library under user lib to /lib in the view from the application in Graphene. In SGX, this also includes hashes of any trusted files to ensure that you're getting the version you think you're getting at runtime. A manifest is sufficient to completely define the initial state of a Graphene application and derive MR enclave. I also want to note that the current syntax is pending a rewrite to be more intuitive, but the same concepts and contents will be present in the new syntax. So here's an example for a simple hello world file. I want to call out a few things first around the issue of creating file system mappings. So first, we can set the LD library path, which searches which controls what the application searches to find libraries, to be /lib in the virtualized view of the file system. These three lines under fs.mount create essentially a unioned and virtualized view of the host file system, essentially translating the build and runtime directory for my Graphene build to /lib in the enclave's view. Finally, at the bottom, I want to specify two libraries that I trust, which permits read and execution inside the enclave. A lot of the work here is about mapping allowed files. The rest of the work is mostly about configuration. So the first line in this manifest basically specifies where to find Graphene and to preload it at runtime, because it won't otherwise be a dependency of a dynamically linked application. And we can set a few parameters like the maximum size for the BRK region and the stack size. So to run Hello World in Graphene, we have an example in the source code under libos shim test native, and you need to build it with the SGX variable set to 1, and this SGX token step signs the manifest and populates hashes of trusted files. Finally, to run the application in an enclave, instead of calling hello world directly, you would call the pal loader, which then actually loads hello world inside of an enclave. And this environment variable sgx equals 1 directs the pal loader to place this in the enclave rather than in a normal host process. So again, making SGX tokens generates the signatures and other cryptographic goodies needed for attestation and measurement at launch time. This is a required step for running in SGX. It is not required for non-SGX mode. One useful feature of our manifests is the ability to create manifest templates. So for instance, you may have a directory with a lot of utilities that all have essentially the same configuration. So one can create a skeleton file named manifest.template that covers all the executables in a directory. Our syntax also includes some macros to capture common variables, such as the location of the build directory. And for individual files, suppose you have 10 files in a directory and 9 of them can use a default, but the 10th one needs some other one-off features. You can also create a binary specific template like hello.manifest.template for the hello binary. And the name of the binary is the first part of this path name. Include a number of additional useful features. For instance, you can turn on debugging support. You can also configure network behavior similarly, either allowing certain port accesses or only loop back, etc. Finally, there are some SGX specific configurations that I mentioned, the enclave size and the number of threads, at least for SGX version 1. We also have some options around file system access. So in particular, there are 3 types of file mappings you can create. There are allowed files that are untrusted inputs that you can read, but they're not checked at all at runtime. They're just, as the name implies, allowed. There are trusted files that are integrity checked, but stored in plain text. This is transparent to the application. If a file that's trusted is tampered with, the read or the load will fail. Similarly, protected files are both encrypted and integrity checked, and again, this is transparent to the application. For those of you working on this at home, if you have additional questions or need help, we have resources both in our documentation, our email support list, which is publicly archived, and our Slack channel. Thank you.